in this calculator, this is a binary calculator. Each bit is represented with a redstone lamp, basically a light bulb. So this is the ones, the twos, so on and so forth, all the way up to 128. So it's 1 through 8, and then 16 through 128. Same on this side, and then this is 1 through 16, and then 32 through 256, because there are, you need an extra bit there in case you're adding up to something that is larger than 128. So, really fast, we're going to do a demonstration to show that the addition works. That's how we're going to start this. So, on this side we're going to put in 220 and then 86, and in the middle we should get 306. So this is going to be a 1, 1, 0, 1, 1, 1, 0, 0. And as you can see, it lights them up in there, because it's adding it with 0 right now. And then 86 is going to be 1, 0, 1, 0, 1, 1, 0. And so when they add together, we should get 1, 0, 0, 1, 1, 0, 0, 1, 0, which is what we got. The redstone lamp on means a 1 and off means a 0. I didn't say that earlier. So yeah, this worked. But what's to say I just didn't wire this up so that it would show this when all these were on. So we're going to show another set of, we're actually going to show 3 sets of numbers in total. So we're going to turn all of these off. Alright, and you turn the other side off too. You can see the numbers changing in the middle as I turn these off. Okay. Okay, there we go. Now it's going to be 59 on this side and 106 on that side. So on this side it's 0, 0, 1, 1. 1, 0, 1, 1. I apologize, I'm reading off of notes I have in front of me right now for the binary because I didn't want to have to calculate them in video. And then we're going to have this other side. We're going to have 0, 1, 1, 0, 1, 0, 1, 0. And so this should add up to 0, 1, 0, 1, 0, 1, oh crap. Yeah, 0, 0, 1, 0, 1. My notes were wrong there. I apologize for that. So, as you can see, this one worked too. And in case you were wondering if there's somebody behind here flipping switches, there's not. It's all circuits. The only person in the world right now, although I don't remember how to pull up the player list, so I can't prove that. So let's do another set of numbers. We're going to do 76 and 49. So this is going to be 0, 1, 0, 0, 1, 1, 0, 0. And then on this side, we're going to have 0011 0001. And so our solution should be 0 0 1 1 1 1 1 0 1. Yeah, I lost my place on my notes, so I apologize. So as you can see, this one works too. And these were 3 randomly selected numbers. They were pre-selected so that we could do all the math and figure everything out beforehand, but they were randomly selected by just random individuals, some of my friends who happened to be nearby. So this all works just fine. Now, how does it work? Well, all the workings are back here. Redstone in Minecraft is just like electricity, and so we used redstone. And there's some weird quirks about it, like these redstone elevators, but it all works just basically like electricity would. And there's a lot of circuits and stuff, and this is a bit too crowded to really be able to demo what's happening internally. So I'm just going to come over here to some preset, some just set up gates that I made earlier. So this is a NOT gate in Minecraft, which means if this lamp is on, this one should be off. And as you can see, that's on, that's off. But if this is on, or if the input is off, the output should be on. So I'm going to turn that off, and this one turns on. So as you can see, that one works. Alright, next we have an AND gate. And if both inputs are on in an AND gate, the output should be on. But if one or the other, or both, is off, the output should also be off. So both on works, and then turn one off, it turns off. Well, that's good. Now if we turn the other one off, it turns off, and both off, it's still off. So this is good. Now if we come over to the next gate, this is an OR gate. So an OR gate, if one or the other or both of the inputs is on, the output should also be on. But if both are off, it should be off. So as you can see, both inputs on works just fine because it's on. I turn one off, and it's still on. That one back on, and that one off, and it's still on. But if I turn this one off, it turns off. Okay, now the most complicated gate that we built is an exclusive OR gate. Took me probably about 30 minutes to come up with the design for this. And so, in an exclusive OR gate, if both are on, the output should be off. Both inputs are on, the output should be off. If one or the other input is on, it should be on. And if both are off, it should be off. So, both are on, and it's off. If I turn one off, it's breaking. What is going on? There we go. It was just a little glitch in the system there. Had to force it to update. So, as you can see, just one on and it's on. Now if I switch these back, it's still on. And then both off, and it's off. So as you can see, all these gates work just as they're intended to. But the way in which they're used causes a little bit of lag, which you can see over here. So, since Minecraft is running on a computer, it can't really beat out a computer in terms of speed, because it's limited by the computer that you're using. and if it tries to update too quickly, it will cause glitches. So because of that, I just turned all of these on. This is, right now, this equals 255. If I turn one more on, it will equal 256, and this one should be the only one that's on. So I'm going to add one from this side. Now you can actually watch as it updates. This is a demonstration of the lag that happens as the circuit moves up through the ranks, and there you go, it's 256. So it all calculates correctly, it just takes a bit of time. I would not recommend using this instead of like an actual calculator that's just built to be a calculator. However, it is a fun applied logic project that we did. And actually, something that's kind of fun to watch is if you flip one of these switches, you can actually see it go all the way up the elevator, and it switches all of these redstone torches. But anyway, so this is our binary calculator, and as far as I can tell, it seems to be working correctly.